Hey guys, what's up people? How are you guys doing? Hoping that all of you guys are doing good. Welcome back to yet another amazing session. So today people, this is the third session of 10th grade electricity where we'll be talking about resistance and factors affecting resistance. But before that, let me introduce myself. My name is Anoop. I'm a master teacher of science here at Vedantu. A very warm welcome to all of you guys out there. So people, today our focus is going to be on understanding this one particular topic, that is resistance and factors affecting resistance. Now in the last session we understood a little bit about resistance. If you haven't watched the recording already, or if you haven't watched the video already, please watch the video and attend this one so that you get the idea of what we are doing. So today we'll be understanding about the factors that is affecting resistance. But as always, I would like to start off this session also with a very interesting quote, and the quote is this: your goals are the roadmaps that guide you and show you what is possible for your life. And that, my friends, is the fact of life. Because when you don't have a goal, like for example, if you walk out of your house and you do not know where you want to go next, you'll just walk around in circles. So in the same way, guys, in life also, you should always have a goal, whether it's short term, long term, does not matter. It could be for the very next day, it does not matter, but still have a goal, and that would help you to propel forward with a sense of purpose. So yeah, enough bashing. Anyways, with that said, guys, in the sessions ahead we'll be talking about the rest of the topics as well. So far we have done about current and potential difference, and we also understood about Ohm's law in the last session. So today we're going to be understanding about resistance and factors affecting resistance. So without any further ado, guys, let us get started. But before that, guys, remember in the last session I gave you a homework. Every session, at the end of every session, we have a homework. So last session also, when we talked about Ohm's law, I had given you a homework. I hope you guys have done it. So here's the question, people. Calculate the potential difference between 2 points of a terminal if an electric current of 10 ampere is flowing through a resistance, or it has a resistance of 20 ohms. So they've given you the current, they've given you the resistance. You're supposed to find out the potential difference. Now, it's a very straightforward question. I would suggest you guys to go with the Ohm's law. So V is equal to I into R, or IR. So in this case, they've given you what is the current, that is 10 amperes, and they've also given you the resistance, that is 20 ohms. Direct substitution, I don't think anyone would have gotten this wrong. So that's 200 volts. So that will be the answer for this question. The potential difference would be 200 volts. Congratulations, guys. Keep the good work, keep it up. All those that gave the right answer, it's a direct substitution, but nonetheless it does take some effort from your end to do it, so hats off to that. Alright, anyways, guys, now we're going to talk about resistance. So in the last session I told you resistance, what the obstruction offered to a flow of current. So when a charge is flowing through the conductor, the resistance or the obstruction offered to it is what is called as resistance, or that obstruction offered to it is what is called as resistance. Now the thing is this, guys, let's talk about it a little. Now, when a potential difference is applied, that is when you connect a battery to it, you're creating a potential difference, and the electron starts flowing. So there's a flow of current. So the electron starts moving from one place to another, from one end to the other, from the negative terminal to the positive terminal. So there is a flow of current happening. Now, when it is passing through the conductor, there are a lot of other electrons as well as protons inside the conductor, because everything is made up of atoms, right? Even if you talk about copper wire, it is made up of copper atoms. So everything in the world is made up of atoms. So here also you have atoms lying around from the end to the other end. Now these atoms will have protons, electrons, neutrons, everything. You guys already know about it. So the electrons, the free moving electrons, start moving from one end to another. And as they are moving from one end to another, what happens is that they start colliding with the other electrons and the protons present inside that conductor. And when it is doing so, what happens is that the momentum of the electron is lost. Now, it's much easier to understand with a very simple example. For example, when you're playing carom, you see that the striker, you imagine you have a striker and you hit it like you have a coin and you hit it. So what happens with the striker? Once the striker hits the coin, the striker's momentum is lost and it slows down, right? The exact same thing happens over here also. So the electron, as it is passing from one into another, as it collides with the other electrons and the protons present inside of the conductor, what happens is there's a loss of momentum happening, and because of that the current slows down. And this, my friends, is what is resistance. The collision is what is resistance. So when there's a collision happening, what happens is that the flow of electrons basically slows down. There's a slowing down happening, and that, my friends, is what is called as resistance. So guys, in the last session I told you that when you talked about Ohm's law, I told you that V is equal to I into R, or V is equal to IR, right? And I also told you that if I rearrange the equation to get R will be V by I. Now here's one thing that I did not tell you in the last session. See guys, just because the equation is resistance is equal to voltage by current, or potential difference by current, you cannot say that if voltage increase, or if you increase the potential difference, the resistance would also increase. No, it does not happen. If this increases, this does not increase like that. No, because resistance is a constant value. So resistance is a constant value. So for a particular conductor, for a particular in an electrical equipment, the resistance is going to be constant. It's not going to change with the increase in the potential difference or with the increase in the flow of current. It does not happen. It's not directly proportional. No, it does not work like that. So as to change the resistance, I can do it two ways. One, change the material itself. Much more simpler that way. Replace it with another one. Or I could change the geometric structure of it, or maybe increase the length of it, or maybe increase the size of it. That is one more way to tackle this problem. So we're going to talk about that. What are those factors that basically affects it? But before that, guys, you have to understand this, that more is the collision, more would be the resistance, and lesser is the collision, lesser is the resistance. Because when an electron is passing through a particular conductor, imagine there's a conductor over here and there are a lot of other electrons and protons over here spaced in different places. So what happens is that when there's less collision, obviously the resistance is also less, and when there's more collision, obviously the resistance is more. So in certain cases you need more resistance, in certain cases you want lesser resistance. So as to to tamper with this value, to change that value, I could basically talk about I could figure out what are the factors that affects it and change that accordingly, so that I can change the value of resistance as well. So resistance in a conductor, in simple words, is what is basically the result of the collision. And if I increase that collision, the resistance increases. If I decrease the collision, then the resistance would decrease. So we're going to talk about what are the factors that would help us do that. The first thing, people, is basically the length of the conductor. So the first factor that affects the resistance is the length of the conductor. Now there's a very simple way to understand this. Okay, I always take the example of you walking on a road. So let's say that you have a narrow road, all right? So you're supposed to walk from let's say that you're supposed to walk from here from point A to point B, and it's like, let's say it's 100 meters, all right? There are 100 meters. You're supposed to go from point A to point B. Now it's a narrow road, and let's say that there are like 100 people. Let's say that there are 100 people in between you. So obviously if it's a narrow road, it'll be much more hard or much more difficult for you to go from point A to point B. Let's say that now you are supposed to go from here to here, but this time the length is 200 meters, double of that. All right, this time the length is 200 meters, and let's say that you have 200 people in between. So which of these do you think would take lesser time for you to get from point A to point B? If I'm pretty sure that you have gone with option number A, that is the first one. Why? Because the length is small, and so it takes much less effort from your side to go from point A to point B. But whereas in the second case, where there are 200 people and the distance is also 200 meters, it'll be much more difficult, or it'll take a longer time for you to get from point A to point B. In the same way, guys, imagine there's one electron, all right? There is resistance. Obviously, there are a lot of other electrons, a lot of protons present inside the conductor. So when it's going from one end to another, there'll be collision. Obviously, it's not like there's someone to guide it. So it's going randomly. So obviously, it'll have some collision. So when it collides, obviously, there's some momentum lost. And so obviously, there's resistance. Now, in this case, this one electron might reach there in a couple of seconds. In this case, it might take a longer time because there are a lot more collision or a lot more obstruction offered. So from this, guys, what you can say is this, that when the length is more, the resistance is also going to be more. More is the length, more would be the resistance, because again, there's a lot of collision happening. So the electron basically slows down a lot more often than in the first case scenario where the length is much more smaller. Alright guys, so that is the first factor. Moving on to the second factor, that is basically nothing but the cross-sectional area. So this one you can write it as resistance is directly proportional to the length. So if length increases, resistance would also increase. Second one is basically the cross-sectional area. Now same example, 100 people, all right, so you have a narrow road, you're supposed to walk in a narrow road, all right, 100 people, you're supposed to go from point A to point B, all right. Yeah, people is what I can, because every time I think about this, I think about Avenue Road. If you've ever been to Bangalore, Avenue Road is one of the most crowded places, so that's why it comes in my mind. Anyways, now here's the thing, there's a narrow road, 100 people, you're supposed to go from point A to point B. Let's say that the road becomes a little more wider. There are same 100 people. There is 100 people over here. There are 100 people over here also. And the distance is also the same. I'm not changing the distance. But in which of the scenarios would it be easier for you to go from point A to point B? I'm pretty sure you'd have gone with option number B this time. Why? Because you have more space to walk. You have more space to move around. So when the same, if we talk about electrons also, when there's more space for the electrons to move around, they will reach from point A to point B much more faster than a simple electrical wire which has lesser thickness. So more is the thickness, or more is the cross-sectional area of the conductor, the lesser would be the obstruction, so lesser would be the friction. So in this case also, it'll be much more, you can get to from one place to another much more faster in this case compared to this one. Here it'll be much more slower because the road is narrow, so you have to basically push people around and finally get there. But in the second case, it'll be much more faster because you have more space to work around. So here it's the exact same thing for electrons also. Because the cross-sectional area is more, it has more space to move from one place to another. So my friends, what I'm trying to say is that if the cross-sectional area is more, then the resistance would decrease. That means R is indirectly proportional to 1 by the cross-sectional area or area. So indirectly proportional to area. That's it. So it'll be 1 by A. A stands for area over here, cross-sectional area. Now, so far what you've seen is this, that the resistance is directly proportional to the length of the conductor. Resistance is also indirectly proportional to the cross-sectional area. Now, if I have to write it as 1, I can write it as R is directly proportional to L by A. Very simple. R is directly proportional to L by A. Now, what I'm going to do is that to remove this proportionality constant, I'm going to introduce a constant called as rho. Now, what is rho? I'll tell you that. So, if I remove that proportionality, to remove that proportionality constant, I'm going to introduce a constant called as rho. So, the formula then becomes R is equal to rho L divided by A. Now, people, what is this rho? Let's talk about that. This rho in physics, it's called, in the world of physics, it's called as resistivity. All right, I'll tell you what that is. But before that, let me just take you through what it is. So this is what the formula looks like. Now, I want every one of you guys to first take a quick screenshot of this, because this is going to superbly help you in your exams as well as in solving problems as well. So make sure that you take a quick screenshot of this, that R is equal to rho into L by A. One way to remember this, I found this on the internet. One of the mnemonics to remember this is, remember this formula to be like replay. You know, replay, like for example, replay. R-E-P-L-A-Y. There's no Y over here, but if you just consider this equal to sign as E, and then there's a P, that rho is P, L, you already have a L, and A, just add the Y. So that's it. So it'll be easier for you to remember. It's a mnemonics that I found it. So it's replay. So it's a very simple mnemonics. It's easier to remember. That's all. So replay is R-E-P-L-A-Y. That's it. So just remember it like that. It'll be much more easier during the exam. So this concept, like I told you, is what is called as resistivity. So here is what resistivity is. Resistivity is nothing but the property of the material to offer resistance. Now, what do I mean by this? Here's the thing, people. Certain materials, like for example conductors, they have very less resistance. All right, or they offer very less. Resistance because the resistivity is low. Whereas certain materials like insulators, like rubber, they have higher resistivity, so the resistance is more. So basically, it is a property of the material to offer resistance. So what is the point of this? is basically for me to understand which, or basically for me to compare which is a better conductor. So by using resistivity, I can tell whether copper is a better conductor or whether aluminum is a better conductor, or I can compare whether aluminum is a better conductor or gold is a better conductor. So by using this value of resistivity, I can know which is a better conductor, which means whichever offers lesser resistance would be the better conductor, because obviously the resistance is, I want least resistance for the flow of current. I want it to flow fast. The rate of flow should be more, so that there should be no loss. That's what I'm trying to say. I don't want any sort of loss. And by comparing the resistivity of different materials, I can choose which is the best material for a particular instrument, or for a particular electrical equipment. So in definition, guys, resistivity is nothing but the resistance offered by a conductor of unit cross section and unit length. How did I come to this conclusion? See guys, R is equal to rho L by A. So if I rearrange the equation to give me rho, so rho would be what? Rho would be equal to RA divided by L. So A goes to the other side. Simple arithmetics again. So by this, guys, again, resistance is constant, so I can say that resistivity offered by a resistivity is the resistance offered by the conductor of unit length and unit cross section. That is 1 meter square by 1 meter length. So by doing that, I'll be able to find out what is the resistivity. So the SI unit of resistivity is ohm meter. Again, how did I come to that conclusion? The SI unit of resistance is ohm, and the SI unit of area is meter square, and the SI unit of length is meter. So one of the m gets cancelled, so it'll be ohm meter. So the SI unit of resistivity is ohm meter. So this is one of the factors that also affects. Like I told you guys, you can also change the material to increase the resistivity. Again, I can choose a different material to increase the resistivity, or I can either change either the length of it or the area of it to tamper with the resistivity of a particular material. As simple as that. Now, there are certain, like I told you in the last session, I told you there are electrical equipments called as resistors, which basically increases the resistance of a particular circuit. So you have, the resistor itself can be made up of different kinds of it can be made up of metals, or it can be also made up of carbon compounds. So whichever material I'm using, the resistivity would also increase accordingly, because again, resistivity depends on the material itself. The property of the material is what is resistivity. What are the properties? How much restriction is it offering to the flow of current? That, my friends, is what is called as resistivity. So resistivity is one of the factors that affects the resistance of a conductor. Simple as that. All right. So far, what do we see? We talked about the length. More is the length, more is the resistance. The more is the cross-sectional area, lesser is the resistance, and also the resistivity of the material. So more is the resistivity, more would be the resistance offered by the circuit as well. Another important factor that affects the flow of current is temperature. Now I have to say one thing, guys. In the last session, in the flow, I told a silly mistake. I made a silly mistake by saying that if the temperature increases, the flow of current increases, but it's actually the other way around. I'm sorry about that. In the flow, I just got lost. But nonetheless, guys, if the temperature increases, then what happens is when you give heat energy to it, what happens is that the electrons and the protons and everything get the energy and they start moving more randomly. See, everything is in motion, all right? But when you give more heat energy to it, what happens is that they start moving more randomly. So when they start moving more randomly, you see this, if you look at the GIF, the electrons would collide even more, because the protons are also moving. What happens when the electron is moving? It'll collide more. So the obstruction offered would obviously increase, which means the resistance would actually increase when the temperature is more. On the other hand, when the temperature is less, the resistance is going to be less, because the randomness of the particle is comparatively lesser. So when the temperature, once again guys, when the temperature is more, there are more heat energy, there are more energy. The protons and electrons gain more energy, they start moving more randomly, and when they do that, the collision would also be more, which means that the resistance is more, and so the flow of current would be much more lesser. Whereas on a cold wire, or the wire at a room temperature, would basically have lesser resistance, which means that the flow of current would be much more faster. So as the temperature increases, the collision increases and the resistance would also increase. Alright guys, so in conclusion guys, what are the factors that is affecting resistance? Let's take a look at it one more time. Length of the conductor is one thing, more is the length, more is the resistivity, or more is the resistance, sorry. Secondly, the cross-sectional area, more is the cross-sectional area, more is the area for the electron to flow, lesser is the resistance. Third is the resistivity of the conductor, that is the property of the material itself. If the material offers less resistivity, or if it has less resistance, then resistivity, then the resistance offered is less. And on the other hand, if the resistivity is more, then the resistance would also be more. And temperature also one more factor. More is the temperature, more would be the resistivity of, or more is the resistance, not resistivity, resistance. All right. So in conclusion guys, that is all we have seen so far. So we'll do some questions right now, a couple of questions, couple of interesting questions, and also a couple of straightforward MCQ questions as well. I want everyone to write down the answers in the comment section below and let me know what are the answers for each and every question. So here's the first question guys. The area of cross section of wire becomes half when its length is stretched to double. The new resistance of a wire becomes halved, double, 4 times, or 1/4 of it. So here's the question guys. The area of the cross section, of wire becomes half of it. The length is stretched to double. What happens to the new resistance? It's a very simple question. You could try it out by yourself. Actually, I'll just give you the simple basic formula. I want all of you guys to try it by yourself. So I know that resistance is directly proportional to the length of the conductor, the current carrying conductor, and also the cross-sectional area. So this is the relationship I know already. Now I know that the length is basically doubled. So it is 2L, or basically the new length is 2L, and area is half of it. So area is halved. So it'll be 1/2 of it. Substitute that over here. So it'll be 1/2 of A. Take 2 to the numerator. So that'll be R is equal to 4L by A. That means that the resistance increases 4 times. So it'll be not equal to, sorry, proportional to L by A, so it'll become 4 times. That is what it means. So the right answer guys would be option number C, that is the resistance would increase 4 times if the cross-sectional area has been decreased to half and the length of it has been doubled, then the resistance would increase 4 times. That is what it means. Alright guys. Anyways, moving on to the second question. I hope you guys understood this second question. Here we go. The resistance and the length of the wire are inversely related, directly related, not related at all, or inversely proportional. The resistance and the length of the wire are inversely related, directly related, not related, or inversely proportional. Direct answer. I want you guys to write down the answer, K, B, C, or D. Pause the video and write down the answer. I want all of you guys to do that, alright? Anyways, the right answer for this question is directly related, guys, because you know that the resistance is directly proportional to L, so if length increases, the resistance would also increase, alright? Next question, here we go. The resistance of a metal wire of length 5 meter is 10 ohms. If the area of cross section of the wire is 3 into 10 to the power of minus 7 meters square, calculate the resistivity of the material. Your options are option A, 4 into 10 to the power of minus 6 ohm meter, 6 into 10 to the power of minus 6 ohm meter, 6.86 into 10 to the power of minus 8 ohm meter, 7.06 into 10 to the power of minus 8 ohm meter. Once again, people, it's actually a very simple question. The calculation might be a little, like a tiny little hard, but then the formula and everything is actually pretty straightforward. So here's the thing, guys. I know that I have to calculate the resistivity. So resistivity is equal to the resistance into the cross-sectional area divided by the length of the conductor. Substitute the values over here. The resistance offered is 10 ohms, 100 ohms. So 100 into the area is 3 into 10 to the power of minus 7 meters, a meter square. I'll just remove the unit because you guys know already what it is. So that's 3 into 10 to the power of minus 7, sorry. And also the length of the conductor is 5 meters. So 5, 2 to the 10, 20. So that'll be 2 into 6, 3 to the 6. So 60 into 10 to the power of minus 6, which can be written as 6 into 10 to the power of minus 6 ohm meter. Simple as that, guys. So the right answer to this question would be option number B, that is 6 into 10 to the power of minus 6 ohm meter. As simple as that. Very straightforward, simple as a question. I think that everyone would be able to do this. Well done, people. Congratulations. Next question. Calculate the resistance of aluminum cable 10 kilometer long and the diameter is 2.0 millimeter if the resistance of the aluminium is 2.7 into 10 to the power of minus 8 ohm meter. You're supposed to find out the resistance in this situation. Is it 80 ohms, 86 ohms, 90 ohms, or 73 ohms? So for this question, guys, first of all, write on the given data. All right. So the length of the cable is given as 10 kilometer. Now, first thing, make everything into the same unit. So 10 kilometers in terms of meter, that will be into 1000 meters. So 10 into 1000 would be okay, that's 10,000 meters is the length of the wire. All right, the length of the wire, because 1 kilometer is 1000 meters, so I'll multiply it with 1000. It'll give me 10,000 meters. The diameter of the cable is given. The diameter is 2 millimeter. All right, 2 millimeter. All right. Now, here's the thing. To find out resistance, I need to know the area. All right. And if you talk about a wire, it's basically, if you talk about the cross-sectional area, it is basically a circle. It's basically a circle. If you talk about the cross-sectional area, it's basically a circle. Now, what I'm going to do is that I'm going to find out the area. So how will I find out the area? So if the diameter is 2 meter, then the radius is 1 millimeter. Radius is 1 millimeter. So millimeter converted to meters now. So I'll take it as 1 into 10 to the power of minus 3 meters divided by 1000. All right. So I'll get it as 1 into 10 to the power of minus 3 meters. Substitute that over here. So I know the resistivity is 2.7 into 10 to the power of minus 8 into the length of the conductor is 10,000 divided by the radius is, so again, I found the radius. Area of a circle is what? 2 pi r square. All right. Sorry, not 2 pi r square. Pi r square. Oh my god. All right. Pi r square. So substitute the values over here. Pi r square. So I'll put it as 2.7 into 10 to the power of minus 8 into 10,000 divided by pi is 3.141 into r is basically, how much is it? 1 into 10 to the power of minus 3. The whole square. So do the calculation, people. I wish I had enough space to do it. I'm going to erase the first part off so that I'll have, oh my god, okay, I just erased everything. Okay, so I'll just write the last part once again. So R is equal to rho L by A, and rho is given as what? It is 2.7 into 10 to the power of minus 8. Sorry about that, people. Happens. So that is 10,000 divided by the diameter. It's 3.141, or I'll take it as 3.14 into 1 into 10 to the power of minus 3, the whole square. So if you do the calculation, you get 2.7 into 10 to the power of minus 8. What to say? Plus 1, 2, 3, 4. That's 4 again. So you'll get it as 10 to the power minus 4 into 3.14 into 1 into 10 to the power of minus 6. So 2.7 into 10 to the power 4 minus 4 divided by 3.14 into 10 to the power of minus 6. So I'll take this to the other side. I'll take this as numerator. So I'll get as 2.7 into 10 to the power minus 4 plus 6 divided by 3.14. So what do I get? So it'll be 2.7 into 10 to the power 2 whole divided by 3.14. So if you do the calculation, that'll be 2.7 into 100. So that's 270 divided by, so you'll get the final value to be, I'll just write this over here. So I'll get the final value. I'll just write it over here, guys. Sorry. So it'll be, I'll get R is equal to 270 divided by 3.14. So if you calculate this, I think you'll get around 85.98 or something you'll get. So the answer would be 86. You can just round it off as 86. So the answer to this question would be 86 ohms. Yeah, I know it took a lot of time, but yes, it's actually a very straightforward question. A couple of here and there, if you just change the values, you would get the answer directly. In this case, you have to find out the area. That is the only extra step that you're doing to get the answer. As simple as that, guys. So that is the answer. With that said, here is the homework. Once again, people, write down your homework, whatever the answer that you get, put it in the comment section below and let me know where you are finding it difficult so I can help you out in that particular situation. Here's the question, guys. Calculate the resistance of a 1 kilometer long copper wire of radius 1 millimeter. Resistivity of the copper is 1.72 into 10 to the power of minus 8 ohm meter. So you're supposed to find out what is the resistance. They've given you the length of the wire, that is 1 kilometer. Again, convert the unit, don't forget that. Radius is given as 1 millimeter. Use that to find out the area, and also find out the resistivity is also given as 1.72 into 10 to the power of minus 8 ohm meter. So you're supposed to calculate the resistance. Simple as that, people. Do it and let me know what is the answer in the comment section below. So that is it from my side, people. I hope you guys enjoyed today's session. I'll see you all in the next one. Take care of yourself, stay safe. Do like, share and subscribe if you want more such content in the future. So, and click on the bell button as well to get notified. And if you want to reach out to me, if you have a doubt, you can reach out to me on this email ID, anoop.manoharan@vedantu.com. And whatever doubts you have, put it down in the comment section below. I'll try to find some time to answer that as well. So until the next time we meet, stay safe and may the force be with you. Once again, people, take care, stay safe, bye bye.